So we've been solving systems of equations using substitution, graphing, and elimination method. Today we're going to look at solving a system of linear inequalities. And the only way that we can solve a system of linear inequalities is through graphing. And so all we need to do is take each of the three inequalities and graph them on the same plane. So I'm going to start with y is less than 4. If I were to graph y equals 4, then that would be a horizontal line here. So let me graph y. And I'm using a dashed line because I have less than 4. It is not an equal to. If it were equal to, I would have a dashed line. A solid line. So then I have to ask myself, which side of the line do I shade? Do I shade above the line or below the line? The way I do that is I pick a point like 0. And if I put 0 in for y, is 0 less than 4? Yes. So that means I shade the side of the line that contains the solution. So all of this down here is a solution for y is less than 4. All right, so now we're going to graph y is greater than negative 2x minus 6. So the first thing I'm going to do is graph it as if it were a line. Since this is the y-intercept, I'm going to come down to negative 6. The slope is negative, so that means it's going to lean this way. The underline here, greater than or equal to, means it's a solid line. So my slope is negative 2 over 1, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And then I need to connect those points. It's really important, however, that you use a straight edge for this, because remember that the solution of a system has to do with where the lines intersect. So I need to know where my boundary is, or where my intersection is. And then I have to decide which side of the line am I going to shade. Well, if I put 0 in here and 0 here, say I usually pick the vertex because it's easy. Is 0 greater than or equal to negative 6? Because when I put 0 in here, this term goes away. It is, so that means I'm going to shade everything on this side of the line. And I'm choosing to do it in a different color because it'll help me with my solution set here in a few minutes. All right, last one. I need to graph x is less than 7. So I ask myself, is it solid or dashed? That's right, it's dashed because there's no underline. It is less than 7, so here's my x is 7. And then now I need to figure out which side of the line to shade. Let's see, if I put 0 in here, is 0 less than 7? Is 0 less than 7? Yes. So that means I'm going to shade this side of my solution of my line. Now you'll notice that I'm only shading the part that overlaps on all three, because the solution to this system would be the points that are in all three of the graphs, and that would be this area of this triangle here. In order to be finished, however, I need to know the boundaries or the vertices of these points. And once I know those, then I'm done. So the point of intersection here is negative 5, 4. The point of intersection here is 7, 4. And then the last point of intersection all the way over here, 14, 15, 16, 17, 18, 19, 20, is 7, negative 20. These three boundaries are going to become important in the next lesson. The key focus that you need to get is that anything that is in the common solution set for the 3 lines is the solution to your inequality. So I'm going to give you another one to try. Here you go. Try this one on your own and come back in just a minute to check.